Town A's population is currently 1,000 people, growing at a continuous rate of 6% each year. Town B's population is currently 5,000 people, but is dropping at an annual rate of 5% each year. When will the two towns' populations be equal? So first let's set up an equation. Since we want our two towns' populations to be equal, we're interested in when will Town A be equal to Town B. So for Town A, one of the key words to notice is that it's growing at a continuous rate of 6%. So we use our initial population of 1,000. Anytime we're growing at a continuous rate, this tells us that we're going to use our base of E. We'll change 6% to a decimal, so 0.06 times t, where t is the number of years that this will take. So let's note that t is equal to the number of years. For Town B, the population is currently 5,000, so we'll use that as our initial value, but it's decreasing at an annual rate of 5% per year. So I'm going to think about my 1 plus r setup from earlier in chapter 4. So 1, my rate, it's a decrease of 5%, so I'm going to subtract 0.05 to the power of t, where t is our number of years. Or if we simplify this, we have 1,000 e to the 0.06t is equal to 5,000 times 0.95 to the power of t. So we have an exponential equation that we need to solve, but it's a little more complicated than some of the past ones we've seen in that we have two exponential expressions with different bases. So this is one where we will have to use our properties of logs in order to help us to simplify. Let's start by working on our leading coefficients. Since one side has a leading coefficient of 1,000 and the other side 5,000, I'm going to go ahead and divide both sides by the smaller value of 1,000. So that I have e to the 0.06t is equal to 5 times 0.95 to the power of t. So I'm going to use my log property. So I'm going to start by taking a log of each side of my equation. I get to choose the type of log. So I'm going to choose a natural log, knowing that will help me to simplify when I have a base of e. So I'm going to take the natural log of the left-hand side, set that equal to the natural log of the right-hand side. So on the left-hand side, we're able to do some simplifying here. We can use our exponent rule to bring our exponent out in front. And remember, by definition, the natural log of e is equal to 1, since it's log base e of e. So this side is going to simplify to just 0.6t times 1, so just 0.06t. On the right-hand side, keep in mind that this is really a product, a multiplication between 5 and 0.95 to the power of t. So we cannot use our exponent property yet because that power is just on the second factor, it's not on the 5. So what we want to do first is use our sum property that says if you have a multiplication, we can turn it into two logs being added together. So we'll have the natural log of 5 plus the natural log of 0.95 to the power of t. Now on that second term, we are allowed to use our exponent rule and move our t out in front. So we have 0.06t is equal to the natural log of 5 plus t times the natural log of 0.95. So we have three terms at this point, and I want to get the terms that have a t, this one has a t and this one has a t, on one side together, and the one that does not have a t, our natural log of 5, leave that on the other side by itself. So I'm going to accomplish this by subtracting t times the natural log of 0.95 from both sides. Let's come up here. So we now have 0.06t minus t times the natural log of 0.95 is equal to the natural log of 5. So those two terms on the left have something in common. They both have a factor of t, so I'm going to factor that out as a common factor, which leaves 0.06 minus the natural log of 0.95. Last, to get t by itself, I'm going to divide both sides by that entire expression, 0.06 minus the natural log of 0.95. So t is equal to the natural log of 5 divided by 0.06 minus the natural log of 0.95. If you're putting this into your calculator as one large expression, these parentheses in the denominator are important to let your calculator know that both of those terms are together in the denominator. So we should get that t is about 14.46. So we could say that after remember, t is the number of years. So after about 14 years, the population is the same between town A and town B. So this is an example of an exponential equation, but one where we have two separate expressions that have the variable and the exponent. Here we need our properties of logs to allow us to solve.